Hello, everyone, and thank you for joining us for today's event, Backup Power Solutions and Renewable Fuels, a critical piece of the energy equation. During this event, all participants will be in a listen-only mode. To ask a question, please use the chat box located in the lower right-hand corner of your screen. Please direct your question to all panelists. We encourage you to ask questions at any time. Your questions will be addressed at the end of the presentation. This event is being recorded. The recording will be available on the Engine Technology Forum's website shortly after this event. I would now like to introduce our moderator, Alan Schaefer, Executive Director of the Engine Technology Forum. Alan?
Great, thank you, Josie, and welcome everyone. Nice to have you all with us this afternoon. A quick word about the Engine Technology Forum. Many of you may recognize us from our predecessor organization, the Diesel Technology Forum. Our new organization expands upon our work and activities that were centered around diesel technology into the broader area of all internal combustion engines as the fuels that they use. And you can see a little more about our thinking here. And I'd like to welcome participants on today's call who represent academia, government, fuel providers, industry, and both our U.S. and international participants. Our session, as you've heard, is entitled Backup Power Solutions and Renewable Fuels, a critical piece of the the energy equation. To make this session possible is totally due to the members of the Engine Technology Forum, and those companies are represented here, and I'm delighted to have two of them as participants here today. Next slide, please. To state the obvious, electricity is central to our everyday lives, from the basics of providing light, heat, and refrigeration to our more modern concerns of connectivity in our digital world. One needs to look no further than the daily news about concerns about the climate, our weather, and the supply of electric power. And the news, well, let's be honest, is often concerning. Recent reports earlier this month by electric power providers sounded the alarm on the ability of the nation's electric grid to deliver the power we need during the coming months, the winter months. Next slide, please. Here at the Engine Technology Forum, we are not experts in electric power supply, but when those who are considered experts suggest we are not prepared to withstand the impacts of climate change, we ought to listen. And as we know, at this very time of power insecurity, we are pursuing a national energy agenda that puts more demands on the electric power system. Next slide. And our power insecurity comes from not just from the periodic, what you might call kind of traditional storms and weather events that might knock down a few power poles for a couple hours, but more recently, parts of the U.S. here are being forced to manage power supply and actually shut it off to help mitigate the possibility of wildfires. And that's particularly front and center in California. And this news clip from a recent time provides a bit of an understanding about the circumstances around cutting off power to nearly 1 million people and what that might mean. California's wildfires have brought particular focus on the role of the electric power grid also in causing some of these fires. And sometimes the grid, though, is the victim of fires that are being caused by lightning or some other source. And the power gets cut off from things being burned, essentially, and disconnected. As was the case here, reported in the September 14th story in the Los Angeles Times, it chronicled the efforts to restore power to this community. And we'll hear more about this in just a moment. As things go now, we are looking more at all of our activities and decisions through the lens of sustainability. And through that lens of sustainability, every person, government, business are constantly looking for the right balance. In this case, the balancing for the demand of reliable electric power for essential uses and to protect public health and safety with the desire to be more sustainable. And when it comes to sustainability in backup power systems, we have a proven and ready solution at work already in renewable diesel fuel that makes up a critical piece of the energy equation. So let's get started with our session today. Here's how it's going to work. We have 3 presentations back to back, and then we'll have time at the end for questions. You can and should submit questions at any time through the chat feature. And I now would like to introduce our panelists. Greg Lamberg from Peterson Power Systems, who's coming to us from Northern California. Matt Leuck from Neste, who's joining us from the Houston, Texas area, and Tammy Klein from Transport Energy Strategies, joining us from Florida. And we're coming to you from the suburban Maryland offices just outside of Washington, D.C. So without any further delay, Greg, I'd like to ask you to kick us off.
Well, thanks for that, Alan, and happy to be here today. Thank you, everybody, for joining in, and happy holidays to all of you. Peterson Power Systems is a Caterpillar dealership. Caterpillar Corporation goes to market through a network of dealerships. We are one of 40 dealerships in North America, and we tend to be number one or number two in power year after year. We are a very large power dealership. Here are some of our stats. We have been owned by the same family for about 87 years. We are currently transitioning to our fourth generation of ownership within that same family. And you can see our territory right here. And as we say at Peterson, what we do matters. And that gives us purpose each day for coming to work and makes us feel good about what we're doing societally to help keep the lights on, to help with construction projects and all types of technologies that we are involved with. Next slide, please. So compression ignition engines are found basically everywhere where you have a critical facility that cannot withstand a loss of power. These are some of the use cases here. We do a lot of work in hospitals, wastewater treatment centers, emergency centers, airports, seaports. But basically, this is the technology, the best suited technology to provide for insurance in the event of a power loss. Next slide. Why? Because not only are these gensets cost-effective and highly reliable. They're so reliable, actually, that in many cases they're legally required in these facilities for backup generation. But the capabilities and the characteristics of these gensets make them ideally suited for a lot of these use cases with regards to their rapid startup, relatively low capital cost. They're very mobile, as you'll see shortly, and they have a real proven track record in providing power when the grid fails. Next, please. So let's talk about a real life example that Alan kind of alluded to in his opening comments here in California this summer. I think all of us have heard about the California wildfires, what's happening there. And, some of these can be started by electric power lines, but many of them are actually started by lightning strikes, as was the case in Del Norte County, the very northern part of the state this year. And I want to thank the Los Angeles Times for making this presentation very, very easy for me. I was able to lift some things out of the Times to share some stuff with you. But the bottom line is, very often when you have a large forest fire like that, a large wildfire, the transmission lines are traversing these areas, and you lose those transmission lines, losing your ability to provide power to these communities, as was the case in Del Norte County, the most northernmost county in California, where 27 residents were without power. And with Peterson's help, for the first time, in history, we believe, an entire county was kept online through the provision of microgrid supplied by Peterson Power Systems. Let's talk a little bit about scale here. Here you can see this is one of the installations at a high school. And we'll look at a few more of these installations and talk about speed and velocity with which we were able to respond. Next slide, please, Josie. So what happens when you lose power? Well, unfortunately, a lot of people learn what happens when you lose power when you actually lose power. And Eric Weir, who was the city manager of Crescent City, the largest city in Del Norte County, said it the best. He says it's life or death for a lot of people when you lose power. So a lot of the emergency authorities went into action as this event was playing out, and Peterson went into action, and we were able to mobilize a significant amount of power in a very short period of time, as you'll see. So on the emergency generation, we were able to basically, our first connections were just within a couple of days. And we were able to, next slide, we were able to connect about 52.5 megawatts of generation, serving over 13,000 customers across Del Norte County just inside of 5 days. And if it wasn't for a major electrical storm that lasted about 16 hours, I think we would have done it inside of 3 to 4 days. So in 5 days, we were able to deploy emergency generation, get it hooked up, and get Del Norte County back online. And we ran that generation for the better part of a month until the system could be re-energized. This was not our first rodeo. We do this at a number of facilities. We have a very large rental fleet, and we have the added ability and the added advantage of being able to tap into the CAT dealer network and work collaboratively with other Caterpillar dealerships to move significant amounts of emergency equipment where it's needed. To the left here, this is a 12 megawatt installation at the Paradise Fire, 24 megawatt installation at Fresno in the center, and Oroville, when we're having all the issues with the dam up there, we actually provided a 40 megawatt installation. We can get these installations online and running typically inside of a week, so we can respond very, very quickly. Next, please. And the good news is that, and as Alan pointed out, the diesel technology forum is now the engine technology forum. Societally, we are moving away from diesel as a fuel and looking at renewable fuels. And this is a slide I use from some of my marketing materials, and I kind of have fun with it. But, can you tell which of these gensets is running on 100% renewable fuel? No, you can't. Well, don't worry. They can't either. And we'll learn more about that. These renewable fuels, especially like HVO and the renewable diesel provided by Neste that Matt's going to talk about, are literally drop-in replacements of fuel where you can drop them into an existing genset and get a significant environmental benefit and some operational benefits without having to go through much of a challenge with regards to the fuel replacement itself. Next slide, please, Josie. So Peterson Power Systems, we like to lead. The view is always better in the front. We were an early adopter of HVO. We do provide turnkey rental services that can include fueling of these systems. And we've been providing renewable fuels to our customers since 2019 at the onset of the public safety power shutoffs. We've done our own independent air emissions testing to prove out the environmental benefits. And we're seeing a lot of our stationary generation customers moving to this right now. And as Matt will outline for you shortly, there are some operational advantages in addition to the environmental benefits. So what I want to leave you with is, if we look at the genset as the baby, we ought not throw the baby out with the bathwater. And we look at the renewable fuels, the bathwater, all we need to do is just change the bathwater because the baby is just fine. So I look forward to the other presentations today. I think this is going to be an exciting program. I look forward to fielding some of your questions at the end. Thank you.
Thank you very much, Greg. Matt, I'd like to introduce you and welcome your presentation.
Perfect. Yeah, thanks for having me. Matt Leuck. I am the technical services manager for Neste here in the U.S. for our renewable road. We call it renewable road transportation, but it's really renewable diesel. We should probably rename that because obviously we power things other than trucks. Yeah, first slide here. Next one, I'm going to give you a quick overview of who we are. Many people haven't heard of us. We're the world's largest producer of renewable liquid products, right? So renewable diesel, nearly in the majority, some sustainable aviation fuel as well. Currently going through some very large expansions as well that are going to more than double our output globally in the next few years. Couple of really high level benefits to renewable diesel before we get into this. You're going to see a lot of different terminology. Renewable diesel is the same as HVO, hydrotreated vegetable oil. It's just kind of a nomenclature thing depending on where you are in the world. We're going to use renewable raw materials, waste and residue, right? And we're going to take that stuff, take the carbon inside of there and turn it into a fuel that can be used again. We're going to give that product a second useful life after it's already done its first job. That's going to help us reduce emissions, both in cylinder, but also globally, life cycle. The carbon emissions that we're going to reduce compared to a fossil diesel here in the US, up to a 75% reduction, depending on how we do it with different feedstocks. And as Greg kind of touched on and can go back to, it is a hydrocarbon. So it is a drop-in replacement for a fossil diesel. It is a direct replacement. It's fully compatible with anything that's currently running an ASTM D975 fuel. So big picture, how are we doing this? If you need 500 horsepower of diesel power, we're not going to break the laws of thermodynamics. You still need a certain volume of fuel and energy to do that, right? The difference is where does the carbon come from? So in the fossil world, you're using fossil carbon, stuff that was sequestered underground for hundreds of millions of years. And where you're going to pull that from underground through drilling and fracking and other stuff. And then it goes through an engine out of the tailpipe, and then it's filling the atmosphere with more carbon. We're going to use what we call biogenic carbon, stuff that's already above ground, that's been captured recently in plants and animal fats because they ate the plants and these other things. So we've got this constant cycle of carbon happening rather than trying to fill the atmosphere more. And this is that really cool, dirty stuff that we use to do it. So when I say waste and residue, this is what that looks like. Right now for us at our company, we can stick it here. We're using mostly animal fat and used cooking oil. There are some other things you can use because they work really well in the process. But the biggest point of what we want people to know going into this is renewable diesel is not biodiesel. You know, there's nomenclature that does kind of cross those lines with bio-based diesel, which is kind of the all-encompassing umbrella that covers both. There's a fork in the road, and we're on the renewable diesel naming side of that for a bunch of chemistry reasons. But the coolest part is it is OEM approved, right? Volvo Trucks actually was the first in the US back in 2015. So 8 years ago at this point, put out some press releases saying we fully support the use of this stuff. And now we have great relationships with all the OEMs, including Greg and the guys at CAT, that are really doing some great work to get the word out there. So this slide is more about the trucking industry, and the next group of slides, I put them in here, not necessarily, we're not going to dive in too deep. I don't want to take too much time. I think the Q&A is way more important here, but just in case the slides are sent out or people want the visuals, I just want you to hear what's going on. We can go to the next one. So when fuel arrives on site, first thing someone's going to notice, it's clear like water, you know, and it's odorless. It doesn't have a smell because it doesn't have these aromatic molecules that you have in fossil diesels. And it also has a higher flash point than some other diesels. So it allows renewable diesel to go into certain applications that may have more stringent safety regulations than just an over-the-road truck. This is the best part for power generation. Well, one of the best, sorry. Fuel has to get stored in a tank. And these tanks have to be vented to atmosphere for pressure equalization and other stuff, which means you get moisture in tanks, and you know you have to have water separators and do water drains. By nature of the chemistry of renewable diesel, it does not hold on to that water. It's going to repel it very strongly down to the bottom of the tank, which makes it really easy to get rid of. Whereas some other fuels will actually bond up with the water, which can start encouraging microbial growth and other things that will plug filters and cause issues. But it's also very, very stable. By nature of the molecule itself, it does not want to break down. So, you know, anything from bio to fossil, your storage life may be 6 months to a couple of years if you need to use additives and polishing services and that sort of stuff. We made the first batch of renewable diesel commercially in 2005. We took some of that, we set it aside at one of our first R&D labs in Finland, when we tested every year for all the markers that you look at for fuel stability, and it has not changed in 18 years. So this is what the fuel filters look like when they're very clean, because we're not putting contaminants into the system, right? If there's nothing going in, there's nothing to trap. So on the trucking side of the world, we've had people skip 18 to 20, 22 maintenance cycles on filter changes because there is nothing to change. At the engine itself, one of the coolest things about the fuel, it's a very high cetane number, which is kind of that performance metric of how quick does the fuel combust. The high cetane combined with low aromatics means there's much quicker, cleaner combustion. You're not producing all these combustion byproducts, namely soot, particulate matter. So that's going to put an easier load or less load on some of the after treatment systems you may have, whether it's EGR, coolers and valves, or DPF systems if you have those, or if you're pre-after treatment, if that even exists at this point, that would be less soot out of the tailpipe at that point as well. Just really quick on the injector deposits and fuel cleanliness. I won't go through the details of all of this, but this came from another engine OEM. The fuel is very, very clean. So Neste is our brand. We are one of 2 diesels in North America that have the top tier certification. The other one is a fossil diesel that has to use just a bunch of additives to get there. We meet the certification, which really centers around engine cleanliness and longevity. We meet that without any additives at all. Just what comes out of the tailpipe of the refinery meets that by a long shot, and then goes on to help customers. Won't dwell on this. This kind of gets back into that soot message, right? We're gonna help put less stress on those exhaust after treatment systems. And again, I'm skipping through most of those. You can kind of look at them later if we get slides out. Now, the best part of this, it's a direct drop in replacement. Remember, there's no blend limit. There's no 5% or 10% or 20% limit. You can run it neat, 100%. What that means is you get all of those environmental benefits as well. You're not getting only 5 or 10 or 20% of the benefits. What you see here, this is how a carbon intensity score is built up over time. Just all of the steps of the process to figure out exactly how much carbon is emitted on a levelized basis of grams of CO2 per megajoule of energy. But this is when we say 75% lower GHG emissions, this is where that comes from. It's adding all the steps. And the 100.45, that's the average fossil number for California. And the 24.29, that's the number for if we were to make fuel using used cooking oil. That's what the value would be. Quickly here, the market is going to grow quite a bit. We're looking at a 3x growth in North America by the end of the decade. So then we get a lot of questions about feedstocks on the next slide here. Feedstock market is also going to grow. The world feedstock market right now is not tapped out. We get a lot of questions about how are we going to feed these plants? Well, trust me, if we're investing the billions of dollars to build the plants, we have a plan to feed them. So we've got you covered. And it's not just these used cooking oils and waste fats we're looking at now. Us as a company, about 20% of our workforce is in technology and development and R&D, looking toward these future technologies that will use lignocellulosics like forestry waste and things, municipal solid waste, even further than that, algae and what we call e-fuels or power to X, carbon capture and electrolysis. So I believe the next slide shows if you take all of those technologies and stack them up, the fats, oils, and greases, that's just a little blue sliver at the bottom there. That's what we're working with now. So when people say we can't eat enough French fries to do all this, well, you don't have to eat all the French fries because look at everything else above that that's coming in the next decade or two. And I believe this is probably the last slide, and we like to focus on this. Everyone thinks, depending on the market, there's a silver bullet for everything, right? Whether it's EV for transportation or hydrogen for certain things or whatever. If you take the global oil consumption out to 2040 and break it up to what's used for transportation, the projected outcome for renewables like liquid biofuels plus electric plus hydrogen, there's still some gaps. So we really do need every solution, right? So maybe some of the other markets go a certain way. Things like backup power gen or power gen in general, these liquid fuels are, I'm not going to say they're a silver bullet, but they're going to go a long way to solving a problem that exists here, while the other guys can take some of the other solutions that fit better for their markets. But we really do need everyone to come together on this one. And I believe that's my last slide. Yeah, there we go. And I see some good questions over here coming in about this, so we'll hit those at the end.
Great. Thank you very much, Matt. And now our final presenter for today is Tammy Klein, the founder and CEO of Transport Energy Strategies. Tammy?
Hi, everyone. Great to be with you today. I'm going to talk very briefly because I also am very interested in the Q&A and the dialogue, but I'm going to talk very briefly about a paper that I recently wrote for the Engine Technology Forum, and it's called The Benefits of Bio-Based Diesel Fuels. And I think some of the themes that Greg and Matt have already talked about really show up in this paper. Next slide, and I'll touch on those. So the paper is publicly available. You'll receive the slides after. So I'm not going to go through this just because I want to preserve the time, but to capture some of the things that Matt and Greg have already talked about. Renewable diesel and renewable diesel biodiesel blends, but especially the renewable diesel supply has grown rapidly for all the benefits that Matt has talked about. A lot of the demand is in response to policy, which I won't get too much into, but there's quite a bit of discussion in the paper, and why. So it's really policy. It is greenhouse gas emission reduction. It's emission reduction from criteria air pollutants. And then just seeing the success, for example, in the on-road diesel fleet, I think there's interest in an expansion of the use of renewable diesel for backup generators, which manufacturers are approving, and the demand is growing fast. But I think one of the gaps here is, and one of the themes that I think the paper really brings up that I think Alan talked about at the beginning of this is that, we are in an energy transition, and there's sort of like this gap period, before we reach net zero in 2045 or 2050. There really are great alternatives like renewable diesel for uses like backup generators to really help propel us on the way to decarbonization. So just as Matt says, we need a number of different solutions, and renewable diesel can be one. Next slide. So this just shows, I think, continuing on with what Matt was talking about, renewable and renewable diesel blends really deliver substantial emission reductions. It's really, really impressive when you think about it. I remember working with Neste when they first sort of came to the US in 2005 and 2006, and it's amazing what has happened in that time period, and the product just continually is improving, and that includes the emission reduction potential as well, as you see here. Next slide. The supply is growing quickly, so you can see in the US the annual existing and expected renewable diesel production capacity, which frankly, this comes from the Energy Information Administration. By my own numbers, I actually think they're much larger, I think, than what is predicted here with EIA. But the supply is growing, and 83% of renewable diesel is being supplied to one state, and that's really because the state has incentivized it through its low carbon fuel standard. Next slide. So for those of you who may not be aware, the low carbon fuel standard it's a very novel policy first proposed in 2007. It's been reconfigured and expanded and revised a couple of times. It's actually under revision to actually make stronger targets for the post-2030 period, but it requires a 20% reduction in the carbon intensity of transportation fuels. So the nice thing about this is with other policies that are on the books, federal policies, tax incentives, and then the low carbon fuel standards, renewable diesel producers are able to stack those values, stack those credit values, and allows them to pass some of that benefit on to end users. So fleets, for example, have been able to purchase renewable diesel at affordable prices. They've been able to meet their decarbonization targets, their interim targets, and also get the emissions reductions from the criteria pollutant side that they're looking for. So it's been an affordable way to address sustainability concerns and keep within targets. Next slide. Other states are looking at following California. So you can see here there are two other West Coast states, Washington and Oregon, that have already created and are implementing and have implemented their own programs. And then there are other states that are looking to do this as well. So I think it's really key for states that are looking to decarbonize the transportation sector primarily, and really those states that are interested in achieving and have announced targets to achieve net zero, which frankly actually is the majority of states at this point. And I think the other impetus for renewable diesel biodiesel plants is really the coming of ESG, sort of getting those reductions in place. And I think once the SEC finalizes its ESG rules, I think that will serve as a demand driver as well. Next slide. So I think the thing is that we need to start thinking about the gap fillers. We're in this sort of transition, and you can definitely see that in the U.S. with respect to the grid. So we see more and more greening of the grid. This chart here is from DOE, and it shows a comparison of what exists today and what's going to be needed in 2035 for a 70% decarbonized power sector and 95% in 2035. So an enormous amount has to be done. So there's sort of this gap between sort of expanding the grid and then providing security and reliability. And I think that's where diesel generators, I think, can really make a huge difference in terms of supporting the grid and supporting reliability. And then renewable diesel biodiesel blends can come in there to sort of support as well, and on a sustainable sort of pathway. So the market is growing. I think there's a lot of recognition, especially for the emergency sector, for large businesses like Amazon, data centers, hospitals, military bases. They're sort of seeing the benefits here in terms of the renewable diesel with generators to provide that security and that reliability, as we begin to expand the grid and green it. Next slide. California, I think, presents a really sort of special case, and I think could be a harbinger of what's to come in the US. So the legislature in 2022 set interim goals of 90% zero carbon electricity sales by 2035 and 95% by 2040. So it's really, you know, those are really big targets. So a massive build out of capacity will be needed. So you see on the slide, the second point, 5 gigawatts of utility scale solar must be built basically every year for the next 20 years, which is 5 times faster than today's rate. So it's an enormous challenge that the state has. Outages are common. There's an increasing unreliability of electricity supply. And I think that what we're seeing is, you know, an increase in use of backup generators, again, to sort of fill that gap. And there are 2 air quality districts, just as an example, in California, South Coast and the Bay Area. They have more than 23,000 backup generators that are nearly all diesel, and they represent about 12 gigawatts of capacity, which is close to about 15% of California's entire grid. So again, you know, we're all headed towards net zero. We're in this energy transition, but we need to sort of fill in some gaps as we get there. Next slide. So yeah, so I think the big piece for me is where we need policies and strategies to support you know, an actual transition. So we know where we're going, but we're sort of in this messy middle, people have said before. You know, one of the drawbacks for low carbon fuel standard is it really incentivizes really superb clean fuels like renewable diesel to go into the transport fleet. And so, you know, what might be needed are, you know, policy options, incentives to sort of, you know, create an opportunity, an expanded opportunity for using those fuels in backup generators. So the paper talks about some policy options that can be considered by policymakers. So, you know, incentives, allowing investor-owned and municipal utilities to generate renewable energy credits, you know, maybe expanding the LCFS to non-sector uses, which there's precedence for that, and other types of policies, especially at the federal level, reducing or eliminating state diesel excise taxes as it applies to renewable diesel and biodiesel blends for these purposes, or creating another type of tax incentives that's GHG reduction based, right? Because we want to keep on the decarbonization pathway. So we need policies that, you know, provide for that or require that, but supports the use of renewable diesel and renewable diesel bioblends in backup generators. So those are all considerations and options for policymakers, not only in California, but nationwide to consider, you know, as we are sort of in this sort of this messy middle in this energy transition and needing to fill in gaps. So with that, I'll turn it back over to Alan and look forward to your questions.
Great. Thank you very much, Tammy and Greg and Matt, for a really interesting presentations. And also thanks to our participants on the audience side for being quite robust in your submission of questions to the chat area. And so let's kind of dive into those now. It looks like we have a handful of ones that are technical on the generator side itself, and then some technical ones on the fuel side itself, and then maybe some broader questions there. And I'll get into the question maybe first for you, Greg, about what's the economics of running renewable diesel versus standard diesel in backup systems like you're accustomed to working with?
Yeah, I would need a little bit of help from Tammy here. She has got a much larger view of this, but you know, like in California, we're seeing a lot of subsidy for renewable diesel, where you know we have a filling station right across the street from our office here in San Leandro, California, where you can go purchase the Neste RD product, the My Renewable RD, at literally the same price as diesel. So we're not seeing too much of a price difference here in California.
Okay. Some additional questions about the use of renewable fuels there, and maybe this one is also for you as well, Greg. Are there any cases use of renewable diesel in peaking power plants or boilers for steam generation or locomotives?
I'm not aware of boilers and steam generation, but most of the boilers out here in the West are natural gas fired. We don't have many liquid fuel fired boilers. We do see it a lot in backup generation. With regards to peaking power right now, especially California, is primarily natural gas. So we don't see a lot of liquid fuel per se in as part of the power generation mix. It's more of an emergency fuel for backup generation and emergency portable generation. With regards to locomotives, I would defer to Matt, but I know there's been work done in locomotives with HVO, and I understand there are a number of locomotives that are running on it.
Matt, you
the locomotive OEMs are definitely doing approvals. All the big ones out there, for especially the new Tier 4 releases, doing 100% blanket approvals. There's also work going on with the Association of American Railroads about the legacy equipment. But yes, it's a diesel fuel, right? So it's a drop in for the D975 out there.
Okay. Another generator type question for you, Greg. Do we need to derate the generator output or performance if you're using renewable diesel, or does things stay the same there?
We have seen some testing where we see a derate of like maybe 1 or 2%, a very, very small derate, but we have not seen a significant derate in the Caterpillar gensets running on HVO. If anything, it's a couple of percent. And Caterpillar did put forth a white paper on this where they did a number of testing, and it goes through this issue in pretty good detail with regards to how that derate arrives and how to account for it.
I was going to say the same thing. The Caterpillar white paper on power gen with HVO with renewable diesel is actually a really good resource. They have some amazing conclusions in there.
And we will provide a link to that and some other resources at the end of today's session. Let's see. I wanted to just maybe make sure we're level setting everyone on the nomenclature that we're kicking around here. So, what's the difference between HVO and renewable diesel, Matt?
Nothing, because Neste was the first to kind of patent this technology back in the 90s over in Europe, and they chose to call it HVO, hydrotreated vegetable oil. As it moved into the US, biodiesel was already here, and this was another form of biodiesel, but we had to differentiate. So it became renewable diesel, so that we didn't introduce even more terms into this market. But there's no difference between RD and HVO, just which side of the ocean are you on?
Okay, thank you. That is quite helpful. There's a big question here about what's the size of the global supply and demand of HVO renewable diesel. And we showed, I think I had a slide or two on that from the EIA information, but you want to comment on that, Matt, at all? What's your perspective on that?
I don't know if the question came in before or after the slide, but I think it was slide 46 and the main deck had some of that information showing that, right now, from looking at this, about 11 million tons a year production globally at the moment, going up to nearly 30 by the end of the decade. So with, a 3x growth in production, mainly North America and Europe, but there's also starting to be some pull and some demand coming in through South America and a little in APAC as well.
Okay. Let's talk a little bit about the subsidy issue and the fact that renewable diesel fuel is part of the low carbon fuel standard in California. The eligibility there for the subsidies is really limited to the transportation sector. And I know, Tammy, that was one of the points that you brought out in terms of the policy issue. And I guess my question for anyone on the panel who wants to answer it is, if we're really concerned about reducing carbon emissions, we really shouldn't care where those reductions come from, whether it's a Class 8 truck or a backup generator, at least in my simple view of the world. What do you say about that?
Well, I will take the first stab at it and say that that I agree. I think that when these policies were created, in particular low carbon fuel standard, I think because on-road transport is the largest sort of part of the carbon budget, I think the focus on policy was on that sector, and it's sort of the same in some sense at the federal level, although there's more available there in terms of incentives. So I think, you know, at the time the focus was there, but I think as we, you know, expand, and there really was just the beginnings of renewable diesel, for example, as an example fuel at that time. But now, you know, we're seeing all of these different types of applications. We have gaps, you know, as I said, that need to be filled. And so, you know, it does make sense to begin, you know, sort of taking a maybe a little bit more of a holistic view of where you can get your reductions and how you can incentivize them. I'm not really sure personally the state is doing that, but I think that other states that might follow California should do that. And I think some are looking.
I would kind of add on to that, you know, working with power gen generator producers and suppliers like Greg and them, but also the end users who are building the data centers and the hospitals. There is becoming a much larger push for RD. And so now we, as the producer, we have our own public affairs team. So we're trying to do our work to make these changes happen. But now we can start leveraging these other companies as well. So we've actually started kind of bringing together everyone else behind us, right? Like, we'll lead the way, but you got to come with us. And we're trying to make these changes happen. It's just, like Tammy said, when the things were written, they were just thinking about trucks. And it's hard to change that ship. You have to now not go through necessarily CARB or anything. Now it's the public utility commissions and other stuff. And so just something to keep in mind as other states start crafting and generating and looking into programs like this. If you have a way, help remind them, please don't just copy paste California, use it as a baseline, but also go a step above and really include these other secondary applications that weren't considered the first time.
Yeah, well said, Matt. I mean, there's over 15,000 megawatts of backup diesel generation in California right now that, you know, could be readily available for, you know, a major power shortage. And what the state's trying to do right now is they're trying to replace that with non-emitting resources, and the technology just doesn't exist to do it. And they're going to spend 600 million plus chasing it and come up nowhere. Where at the end of the day, it's really the last slide. It's replacing the bathwater, not throwing out the baby with the bathwater. So you know, there's real opportunity there, and holistically, we should be looking to incentivize the use of renewable fuels throughout the energy ecosystem.
Well said. Thank you all for that comment. We have a couple of comments getting back into some of the technical and more specific ones about let's look at the overall maintenance cost savings of running renewable diesel versus standard diesel over 10 or 20 years. Matt, you guys have a lot of experience looking at that, and Caterpillar does as well. Are we saving money in maintenance by using renewable diesel fuel?
I can go first and then Greg jump in. So we don't have long-term studies with generators, but we do with diesel engines in general. And we have a ton of customer testimonials and then just telling us their experiences. On the trucking side of the business, you know, we have guys saying we're saving 2 cents per mile just in maintenance costs because you're not diluting your engine lube oil as much, right? Because the fuel is combusting and not getting in the pan. You're not putting as much strain on those after treatment systems. So now you have less downtime, you have less maintenance to do on the DPFs and SCRs if you have those and other stuff. So depending on duty cycle and you know, load case, it's hard to put a number on it, but we haven't had people come back to us and say, man, we lost money on maintenance, you know?
Mm-hmm.
I think that's consistent with what we're seeing, Matt. I mean, the fact of the matter is that the fuel is so clean that it actually saves money on the back end with filters and replacements and those types of things. You can extend those maintenance intervals because, you know, they're not being you know, plugged and clogged as quickly because of the cleanliness of the fuel.
Mm-hmm. There's a couple of questions related to the stability of renewable diesel, and I guess maybe I would frame that in this way. I think as we're all looking at what some of the energy transition areas are, we see a lot of push towards electrifying transportation and replacing diesel engines with battery electric vehicles, particularly on the heavy duty side. And transit bus and school buses also have some considerable experience here that's been reported on recently. That highlights the fact that during temperature extremes, the range and other performance measures of those systems are negatively impacted, meaning that the range, for example, of an electric vehicle might be reduced if it's very cold conditions or needing to run auxiliary heaters, etc. How about on the renewable fuel side? Do we have good stability with renewable diesel at both extremes of the temperature gradient?
Yeah, I would say on the high end, I don't know a top end of diesel performance, right? There's whatever the opposite of cloud point would be, that's not really a concern. But with higher temperatures, it's not going to break down any quicker than it would some other time. But then again, it really doesn't break down. Now, the cold weather performance, yes, cloud pointed things can be an issue depending on where you're running. And I would say it depends which renewable diesel you're getting your fuel from, because there are some tweaks you can make in the production process and some technology and refining choices. And some producers may make a different cloud point fuel than others. I will say that Neste, coming out of a Neste facility in the winter months, we're going to provide -4 Fahrenheit cloud point. At worst case, we tend to be a little better than that because we want some margin for error. Most markets are going to be okay with -4 cloud, especially in, say you have a backup power like a data center with enclosed gensets in a building and stuff. That's really not going to be an issue. We don't have any issues with our fuel, but I can't speak to any of the other ones.
Okay. Another kind of technical fuel question, Matt, for you. How about the lubricity of renewable diesel?
Yeah, so we get this question a lot. It's going to behave just like a fossil diesel would. Since 2007, when ultra low sulfur diesel hit the scene, a lot of people think that removing sulfur removed lubricity. Sulfur doesn't cause a lubricity. It's just the process they use to remove it is hydrotreating, which is what we do to our feedstocks. So just like the fossil guys, we use the same lubricity additives that they do. We just use them in higher doses. We choose to meet the European diesel fuel standard as opposed to the American, and the European standard provides 20% more better protection for those internal parts than the US standard. So we're going to use the same additives you would be getting in the fossil diesel you already have, just in a little more concentrated dose to help maintain parts.
Okay, thank you for that. There is another question that we see occasionally here at the Engine Technology Forum as well, and that is about the issues about feedstocks. And as we look at the great opportunity that's in front of us with renewable diesel and its growing demand every day across all these sectors, there is the question about whether or not there is adequate feedstock supply, not just today, but down the road. And I know that the industry is working hard on that. The Clean Fuel Alliance America and others are constantly looking at these issues and putting out information and forecast. What are your thoughts about the feedstocks and the future supply for renewable fuels, Matt?
If you look at the current feedstock pool, these fats, oils, and greases, waste and residues, most sources will say that right now there's 28 to 30 million tons available per year, but we haven't maxed out that capacity, right? We're not touching every one of those points. It's probably going to grow another 10 million up to like 40 million in the next number of years, because we can't just go punch a hole in the ground and frack for used cooking oil and pipeline it to a refinery, right? We have to touch all of those individual restaurants and everything else. So for us as a company, our goal is to kind of vertically integrate our feedstock supply. So we've purchased companies like Mahoney Environmental Services and Sequential and AgriTrading, and using our capacity, right, our capital, we can help grow their businesses as well to help them to expand into more markets. So yeah, it's not tapped out by any means at this point. And even then beyond that, we have those other technologies.
Tammy, I know you study this as a practice just about every day. What are your thoughts about feedstock and the future for renewable fuels?
I think it's similar to Matt's. I mean, I think we could see maybe some, tightness in the next few years. And you can see, the various sort of deals that are being done, with agribusiness, or, in the case of Neste with the used cooking oil and really developing that value chain, really sort of looking to looking to ag to, to partner with and to, secure feedstocks. But I do see in the long term, especially, as Matt showed, sort of like where technology is going. I see, like Topso, for example, the technology company in Denmark, is working on feedstocks like, municipal solid wastes, other types of wastes. There's a lot of development on, electrofuels, really sort of looking out into the future. So I think we might see some tightness maybe in the next few years, and that tightness will be sort of producer dependent or producer associated. But I think in the long term, I think we'll find more feedstocks, and I think there'll be, the supply will be there, and the technology to be able to process technologies that or feedstocks that are a little more difficult today will be there as well.
Okay. Greg, I wanted to ask you, I know you have the benefit of many years of experience working with customers that have power generation needs. And, what have you seen over time? What have been the trends and sort of how those customers have evolved their thinking about systems and what things work and which technologies they can rely on? What's your perspective on that backup power market?
Well, I think the gold standard is still a reciprocating engine and a fuel tank. I think there's a lot of interest in moving towards what is perceived as cleaner technologies. I think technology should be looked at holistically. I don't see battery energy storage as a clean technology, for example. But I think people are looking towards microgrids. They're looking towards multiple technologies for additional resilience. And I think what we're going to see is we're going to actually see a loading order behind the meter, where you're going to take the first slug of renewable of backup with some solar, and then there'll be some energy storage, and then the reciprocating engine will be last in line. But I don't see this technology going away anytime soon. And I think one of the things that Matt spoke with was about we're talking about the range of this. But one of the issues that hasn't been mentioned yet is the shelf life. And where the shelf life of fossil diesel is 6 months to a year, the shelf life of HVO renewable diesel can be 10 plus years. So I think it really simplifies the backup generation case. We are seeing more and more interest in backup generation, and more interest in these renewable fuels to fuel that backup generation. Just to give you an idea, last year, one of our large data center customers, if you lined up the gensets end to end that we ship to them, it's somewhere, depending on who I speak to, it's somewhere between 5 and 10 miles of gensets. So there's a lot of equipment being placed to securitize energy. And one of the challenges is, from the holistic utility perspective, is with the technologies that are being deployed right now, primarily solar and storage, they really don't provide capacity or resource adequacy where you can hit the button and have them on whenever you want them. And so the backup use case is becoming more and more important and more front and center as our grid employs more intermittent and renewable resources. I think we are going to see growth here. And the HVO thing, I think in that sense, it's not the silver bullet. It is transitional. But when you look at the benefits of this fuel with regards to operationally and from an environmental perspective, it's a tremendous opportunity to decarbonize and cleanse this sector.
Now, I know that Tammy, as part of the work you did for us in the paper, identified, I think there was somewhere in round numbers, 23,000 or so generators that are actively installed in California at the moment. And it's just to be clear for everyone on here, every one of those diesel generators could use renewable diesel fuel starting today without any change. Is that right?
Yes, they can. And just to, those 23,000, I believe, are in just 2 air quality districts. So the Bay Area and South Coast. So there are many more than 23,000, but yeah, they can all use, renewable diesel today, and it aligns with, what the state and localities are trying to do, which is to reduce GHGs and to improve air quality. So it aligns with what they're already trying to do, and it fits nicely. It's an elegant interim solution.
And so literally by switching out the fuel, I can reduce the carbon emissions by, and keep me honest here on the numbers, but 50 to 85% of
Yep.
carbon and other emissions based on feedstocks.
That's right. That's right. So it's absolutely, I think, a win-win. So it allows the state and localities to begin, to continue moving in terms of grid expansion, adding, wind, solar, other renewable energies as they transition the grid, really is what we're talking about, and expand it. While, providing, reliability. And as you pointed out in the first few slides, that is a huge, huge concern. Not just in California, but in other states as well, and for first responders and others that need, power, absolute and total 100% reliability.
Greg, you've been involved a lot with proceedings with various customers there, but also with the government and public and private utility folks. Have you seen any evolution of the thinking of these policymakers, sort of decision makers, about reliability and backup systems, and maybe recognizing that they're really not that easy to move away from, and they do provide a valuable benefit as an installed asset, and through sort of refueling, as we might be talking about here, they could be, sort of a part of the sustainability solution instead of maybe viewed as part of the problem?
Yeah, we are seeing some of that. I mean, it's in the current political climate, it's difficult for somebody to come out in front of that and get in front of it. But behind closed doors, they'll be honest with you. We are advocates of all of the above. I mean, as Tammy and others have said, we're going through an energy transition. We're not going to redo 100 years of infrastructure in 10 years. This is going to take some time. And what we're just starting to see right now, Alan, is revisiting some of the goals and saying we may not be able to achieve the goals on the time frame that we've set. And there may be some relaxation. That the other thing we're seeing is people are really starting to get cost conscious, because the consumer is really starting to get hit with some of the costs of this transition. So obviously, elected officials are starting to get really concerned about that. You saw PG&E just had a 13% raise in Northern California, and as soon as that was approved, they've just filed for another $1.6 billion increase in revenues, and it's got to stop somewhere. So yeah, there is some change thinking. In California, nobody's going to admit they're wrong. They're just going to admit that they didn't give themselves enough time. So they'll double the goal and give themselves 10 more years. So that's the game. That's what we'll see. But there's already some kinks in the armor with regards to maybe we do need to allow ourselves some more time. But there is a tremendous amount of innovation going on. There's a lot of investment in new technologies. And, going to be a very, very exciting time. But at the end of the day, the best insurance out there is fuel to take. And again, we don't see this technology going away anytime soon. And the fact that we can push the easy button and just fuel switch and clean this up, on orders of magnitude, I think that's something that needs to be embraced at a higher level beyond the transportation sector.
Well, that feels like a great place to end this discussion this afternoon. Next slide, please, there. And I do want to thank all of our panelists, Matt and Greg and Tammy, for a really excellent discussion. I hope it was thought-provoking for our attendees as well. We do have some additional resources available on our website, and this is you'll see this in the Each of these is linked to the manufacturer's statement with regards to HVO, renewable diesel fuel use, so you can get a clear understanding of all of the members of the Engine Technology Forum and how they stand for renewable diesel. And then lastly, I just again want to thank everyone for attending our event today. We do have a website that has some resources on there, including the paper that Tammy authored for us and is available for your download. And we look forward to an opportunity to engage with all of you again sometime soon. With that, wish everyone a happy holiday season and a good afternoon today. Thank you all for joining us.
Thank you.
Take care. Thank you.
Happy holidays, everyone.